Renowned Swiss theorist Jean Piaget has greatly influenced our understanding of cognitive development. According to Piaget, by acting on the world, children discover new, more efficient ways of interpreting experience. In the process, they move through 4 stages of cognitive development: sensory motor, pre-operational, concrete operational, and formal operational. A major milestone of the sensory motor stage, which spans the first 2 years of life, is object permanence, the understanding that objects continue to exist when out of sight. In the early months of life, infants have some understanding of object permanence. Alex, who's 5 months old, looks around for the hidden object under the blanket. Notice how he looks, but doesn't search for the object with his hands.
7-month-old Hannah is beginning to search for hidden objects, but her performance is not yet consistent.
All right, now let's see what she'll do if we hide one of these. She loves this little frog. So we'll take this. Yeah, there's that frog. Where's the frog? Where'd it go? Where'd the frog go? Where did that go? Should we find it? There's the frog. If we hide it partially, let's see what she'll do. She can get it if she sees part of it. There she goes. And now, let's see if we can hide it one more time. Let me hide it. Hey, here's Kermit. There she goes to find that frog. And we'll do it one more time. Where's the frog? There it is. There's that good frog. Now, how about I take Kermit? Let's put him out here again. Where'd he go? Where did he go? I know where he is. Okay.
Around 8 months, babies start to deliberately search for hidden objects. 8-month-old Randy successfully finds the hidden toy. Then, around their first birthday, infants master more complex object hiding tasks. Bailey finds an object hidden in 2 successive locations.
We're here, Captain.
And by 18 months, toddlers realize that an object can move or be moved when out of sight.
I don't know where those...
Piaget believed that infants develop new understandings by directly exploring and experimenting with their world. Their boundless curiosity and drive to discover are clearly evident in their sensory motor play. By the middle of the 2nd year, as mental representation flourishes, make-believe play emerges. At first in the form of simple acts with realistic objects.
Talk? You talk on the phone. Hello. Hello. Hello, Ben. Anybody there? Hello, Ben. How are you, Ben? You talk on the phone to me? Hello. Hello. Who's there?
Another form of representation, categorization, can be seen in children's play. Notice how 18-month-old Catherine spontaneously sorts the chips by color. During Piaget's pre-operational stage, the preschool years, the capacity to mentally represent the world extends further. Sociodramatic play, the make-believe with others that involves coordination of several roles and intricate story plots, appears and becomes increasingly complex. And children can engage in pretend with toys that are less realistic. They often imagine objects and events without any support from the real world.
Oh, what else would you like? An ambulance?
An ambulance? Well, did somebody get in an accident?
Well, yes. This morning it said 2 train crashes in India.
2 train crashes were in India.
Yes, just dump truck goes to India, yeah.
Nevertheless, Piaget assumed that the young child's thinking is not yet logical, although many modern researchers disagree.
More water in the pan.
I don't know. It looks like it.
Pre-operational children are egocentric, Piaget claimed, unaware of viewpoints other than their own. Therefore, they rarely reflect on their own thinking. As a result, they do poorly on logical reasoning tasks. Perhaps the most well-known of these tasks are Piaget's conservation problems. Here, 4-year-old Stephen gives a typical pre-operational response.
Water here, Stephen, and can you tell me, is there just as much water in each glass? Can you look at them? Or does one glass have one more water? Or do they have just the same amount?
I think they have just the same.
You have the same amount. So shall I take one glass of water and watch what I'm doing here. I'm going to pour it in to this dish like that. There it goes into the dish, and I'll get all the water out. And now, is there just as much water in the glass as in the dish?
No,
Does one have more?
this one.
Oh, this one has more. Hmm? How come?
Because this is bigger.
Because this is bigger. Do they each have just the same amount of water, or does one have more?
I don't think any has more.
Oh, now it looks like they each have just the same amount of water in them, all right? So now let's watch and see what's going to happen. Shall we take the dish, and we'll take this water and we'll pour it in the dish, all right? There it goes, in the big dish, big wide dish, like that. And now, is there just as much water in the dish as there is in the glass?
No,
Or does one have more?
this has more.
And how come?
Because I don't know.
Oh, hard to tell, huh? What makes you think it might have more?
Because this glass is bigger than the bowl.
Oh, because this one is bigger than the bowl. I see, I see. Now, let's see. Do you think I can pour that water back again without spilling it?
Yeah.
Let's see if I can do it. Oh, I have to try hard here to do that. And see if I can get the water back in the glass. And there we did that. And now, is there the same amount of water in each glass, or does one have more?
I think they both have the same.
You think they both have the same now? I see about that.
Victor, at age 7, illustrates the logical thinking of Piaget's concrete operational stage.
And now I'd like to know, is there the same amount of Play-Doh in this pancake as in this ball, or is there more Play-Doh in the pancake or more Play-Doh in the ball?
They're still equal.
They're still equal, and how come?
Because you only took the ball and made it into a different shape. It doesn't mean you add something into it. You just changed how it looked. You didn't add anything into it. You just changed how it looked.
I see. Now,
But a difficulty with Piaget's theory is that even very young children like Allison, who has just celebrated her 4th birthday, reason logically when tasks are simplified and made relevant to their everyday experiences.
Have more.
I see just the same amount of Play-Doh in the muffins as in the ball. And how come?
Because if you bunch them up again, I'll have the same amount.
Oh, can you show me that? Show me that. If you bunch them up again, you'll have the same amount.
Young children's efforts to categorize objects often reveal that they are less flexible thinkers than their older school-age counterparts. 4-year-old Zachary is able to categorize these objects only by color, while 7-year-old Liesel is able to sort shapes in more than one way, first by shape, then by color, and finally by size. 7-year-old Victor grasps Piaget's concept of hierarchical classification in this class inclusion task.
It's really complicated to tell this, explain. Well, here are all the red. You know that there's more red than blues. Now, if you add these two together, they make a larger number than the reds. Now, this would be all the balls. But if you take away this, then if you take away the different colors, there'd be less. Now, if you add up all the colors together, there'd be more than the red because the red is less than all the colors.
School-age children do better on seriation tasks than do younger children. 4-year-old Stephen finds this seriation task challenging, while 6-year-old Emily easily lines up the straws in order. Because of their improved ability to conserve, classify, and seriate, school-age children are far more capable problem solvers than they were during the preschool years. School-age children think in an organized, logical fashion when dealing with real-world problems that have only a limited number of variables.
During adolescence, Piaget's formal operational stage, young people become better at thinking abstractly. They engage in hypothetical deductive reasoning. Listen in as this high school history class discusses the writings of Luther.
He doesn't believe that good works get him into heaven, so, I mean, it's not like he thinks putting this out there is going to get him there.
But he thinks this is one of his. Yeah, I mean, I would think that he would think he was saved if he's going through the trouble of doing this. So.
See, I think he's worried about it. I think he doesn't know, and that's the whole reason that this comes about, is because he's insecure.
But I don't think he's insecure after he figures it out.
Adolescents are also capable of propositional thought. This math class provides an example.
If a vehicle is a car, then it has 4 wheels, is a true conditional. A sedan is a car. Use the law of detachment to reach a valid conclusion.
If they told us the conclusion that it had 4 wheels, could we automatically go backwards and say it's the hypothesis?
No.
Why not?
Because it could be a truck or something.
Could be a truck, could be an all-terrain vehicle, or could have been anything.
Exposure to a wide variety of situations that require abstract reasoning promotes formal operational thought. Clearly, schooling contributes greatly.